And hey, hello and welcome to the show. It's me, John Park, and I just unhit the mute button, or I unmuted the hit button or something. It's the workshop. Thank you for stopping by. Thanks for jumping in. We got people in our chats. We've got the YouTube chat alive and well over there. Hello to FireX10, who came from the future to let me know that I had accidentally set the date wrong on the title of the show today. I think I got it fixed in some places, but it's probably floating around there as a blog all wrong. But hello and hi to Beatagraf Abdelhagen and Heaven is Real. Nice to see you all. Asking what's with the electronic robot AI rap music on tape loop. There's an episode where I showed how I made that actually. It was, you're not far off. There was an Amazon wand of some kind. I can't remember if that's what they called it. And it was a sort of a little mini satellite Alexa thumbstick, and you could mostly, I think you could use it for normal Alexa stuff. I don't think it could play music, but it's mostly designed to like magnet to your fridge, and you'd tell it when you were out of eggs and Amazon was going to send some eggs your way. Before I got rid of it, I sampled it, and that sample is a way pitched down sample plus some other drum loops and things like that. But that's where that came from. Hey, Johnny Bergdahl, nice to see you. And look, here is our Discord chat. So if you're wondering where the chat is at, if you're on Facebook or something like that, check this out. This is our Discord server. You can get there by going to adafruit.it/Discord. There'll be a link to get you an instant invite over into the server. And then look for that channel right there. That's the live broadcast chat channel. And that is one of many channels that we have, but that's the one where people tend to hang out during the chat. And look who's here. Hey, Andy Calloway and Dan Coliano, Jim Hendrickson, VP Tech Ops. Hello. Hey there, C. Grover. Hey, John Nodge, Johnny Bergdahl, Andy Calloway. Did I say that already? Hello, 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 hello. Heaven Israel said, oh, so you can program sound samples. Yeah, I don't think I have any sound sampler gizmos here today, but I show them sometimes. That was done with a thing called the 1010 Music black box. But we've got some pretty neat sampling capabilities on inside of CircuitPython, or sample playback at least. And I'm going to show some stuff using this little CircuitPython based synthesizer platform that our friend Toddbot put together, and that runs CircuitPython on a Raspberry Pi Pico microcontroller, or a Pico 2. That's what I'm running on there. And I don't think I'll do any sample stuff today with that, but I will show some synthesis. So those are some of the things. What else is going on today? I've got a coupon code for you if you want to go to the Adafruit shop and get some stuff and save some money. I've got a recap of the Tuesday product pick show. I've got a CircuitPython Parsec for you, continuing some of the starburst animation on LEDs with the Neo Trellis. And then I've got a smorgasbord of project things. We're going to talk about the TB303 acid baseline synthesizer. I'm going to show you a little CAD thing, putting together a socket I needed inside of Rhino. And that leads into a joystick upgrade. I got an old PS2/USB joystick. And by PS2, I mean PlayStation 2, not the PS/2 keyboard mouse standard. That's confusing. But I've got an old joystick I got at the thrift shop, and it's got terrible buttons on it, but they're actually arcade button-sized holes, so that's perfect. And I'm gonna show you how to upgrade those with some real arcade buttons. And there's probably some other stuff. Why don't I look at my notes? Is that it? Is that what we're going to talk about? I think that's what we're going to talk about. Oh, and if we have time, I want to do a bit of a nano loop, a little talk and demo about nano loop. This is a sort of chiptune Game Boy synthesizer that's been around for a while. I think I've talked about it before, but I've got a nice setup where I can stream it into HDMI, and I've just been relearning it, so I want to talk about that. Andy asks, is Lars trying to fix that monitor? Yeah, come on, man. What are you up to back there? Freaking me out. I know. I need to get some stuff up on these screens. It's coming soon, I promise. Okay, so let's dive into some of that. First of all, I said that I've got a coupon code for you, and that is Loopy. I'm feeling a little loopy today. So Loopy is going to save you 10% off in the Adafruit shop. So head on over to adafruit.com. That's the store right there. That's all you need to know. You'll be in the store just by going there. Throw things in your cart. If they're physical goods that we can ship to you, then you can get 10% off on them. I don't believe there are any other restrictions. Just can't be software or gift certificates or subscriptions. But if it's real physical stuff that we'll put in an envelope or a box or a mailer of some kind and send to you, 10% off with the coupon code Loopy. Just type that in on the way out. What's happening over in the Adafruit shop? Let me move that coupon code off to the side a little bit. Here is the shop, and we've got some new products listed here. These cool USB cable lanyards that I was talking about last week. Nothing new since then. Lady Ada is just getting geared up on hardware, making new hardware for the new year. So not too much new in the store, but that doesn't mean you can't find some stuff you like. Head over to products and find a category. Maybe you want a RP2040 Pico. How about a keyboard? Those are great. Get a keyboard instead of $895. It would be $895 minus 0.9. Probably round up. That's some neat stuff right there. I'm going to talk about arcade buttons today. We've got a whole slew of different kinds. I like these light up 30 millimeter. That's the standard arcade button size. These are nice and short because a lot of arcade buttons you'll run into, maybe not as common anymore, but I've in the past run into a lot of, this is one I've taken apart, real long, and then there's a additional tact switch, limit switch under there that gets pressed. These are enormous. The 30 millimeter ones with the LED that we sell, nice and short, and they have a nut that you can use to tighten them on the other side of your panel. We also have these push-through types. If your hole is just right for these just snap in place, and that's about as small as they get. But if you want to get some stuff, throw together some stuff for a project and save 10%, then that's your coupon code. That's what you're going to want right there. Loopy. What else? Let's talk about the product pick of the week. So on Tuesdays, I have that show right there. I had a very short-lived Three Musketeers looking facial hair there as I was getting rid of the beard last week. But I decided to memorialize it. Anyway, this was the product pick of the week, and here's a little recap. The product pick of the week this week. This is the micro SD card breakout board plus. Unlike our other micro SD card breakouts, I believe this is the only one that can be used on 5-volt systems. This has a really nice voltage regulator on it and a really nice level shifter on it, so we can take 5 volts and get 3 out where we need it. We can take 5-volt level logic on something like an older Arduino and level shift it over to the 3-volt logic that we need. Blink when I insert the card. So you can see it read the card there. So you can see in my REPL there, when I inserted that card, I read the contents of it and printed it out. And then I have a series of very small bitmap icons on here, and I'm just using the buttons on the clue to read those off of the card and display them. That right there is my product pick of the week this week. It is the Micro SD Card Breakout Board Plus. Yes, that was it. All right. Let me move some stuff around and get ready for the CircuitPython Parsec. I think we're good to go. CircuitPython Parsec. All right. So let me get rid of this diagnostics thing that always pops up. There we go. For the CircuitPython Parsec today, I wanted to talk about creating a starburst animation pattern on the Trellis M4. And the idea behind this would work in any sort of a grid that you have of LEDs. This one just happens to be easy to trigger by pressing a button. So the way this works here is if I press any button on the Trellis M4, it will initiate a starburst animation that flows out from that position and across all of the other LEDs in any direction. So this is something you see on mechanical keyboards sometimes as a built-in pattern for when you're typing. Mine won't initiate multiples at a time. I'm just doing a single one at a time to keep it simple. And this is related to what we looked at last week, except instead of just moving in the sort of cardinal directions, we're now moving any n number away from the initial press and then growing that as we go. So in my code, you can see here, I'm importing time and I'm importing the Adafruit Trellis M4 library. That takes care of very easy high-level commands for things like checking for a button press and knowing on this grid which button it was, as well as lighting up NeoPixel LEDs with any color you want, any brightness, and any of these LEDs on the grid. So you can see here we have an 8x4 grid, 8 horizontal, 4, and this is the 0, 0 point up here in the upper left corner. That's the origin. And so the first thing I do is when I restart the program, let me just relaunch it. First thing I do is I like to light up this corner LED green so they know that I've restarted it and I know that it's on. Otherwise, I don't know if there's power to it. So that's the first thing I do here is I create the Trellis object by saying Trellis equals Adafruit Trellis M4 dot Trellis M4 Express. And then I'm setting the pixel at 0, 0 to a green color. So that's an RGB value there of 50, so it's not too bright, but it's pure green. Then I'm telling my code a couple of variables here. The width of this thing is 8, the height of it is 4. And then I have a few functions here that are going to help me out. First, I have a getDistance function. And this allows me to say, okay, if I've got, let's say, pixel and button 0, 0, what's the distance to this bottom right corner? So this bottom right corner here is going to be the x1, which is 0, and the y1, which is 0, and the x2, which is 7, and the y2, which is 4. Those all get added to this little expression here, which is I return the absolute value, so we can deal with positives and negatives, absolute value of x1 minus x2, so in this case it would be 0 minus 7, but the absolute of that, so it's 7, plus the absolute of y0 minus y4, which is going to be 3. And so that means that the distance between these 2 points is 10. And so that's how we're going to calculate Manhattan distance if we go from here 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 away. So that's a little helper function. And then the main function here is this function called starburst. And this takes an x and a y coordinate for the pixel that we're going to light up. And it has a default color of red, but then we can feed it other colors when we call this function. So the first thing we do is get the max distance that's available on here. I set that as max distance. And then the pixel distances, I'm going to fill that later. And then to expand in waves, we say for the distance in that range of max distance, so in this case it would be 10, for each horizontal and then for each vertical, we go and get the distance between, so initially 0 to 1, 0 to 2, 0 to 3, 0 to 4, 5, 6, 7, growing outward. And then we light that pixel. So if that distance is within the distance away, so I'm not trying to light up pixels that don't exist on the board itself, pixel distance p, x, and py is equal to the distance. Then we dim all of the previously lit ones. So as we march forward, we set the brightness value in hue or in RGB of the previous one a little lower. And I'm dividing that by 3 just so that you can see it fade a bit, but it isn't too slow. If we increase the number of steps, we'll get a slower fade here, which is cool. If we do, let's say, the maximum that we should be able to do on a corner, we get a nice fade there. I am zipping it up fast when I get to the very edge there, so I think it looks best with something like this. Then once we've figured out what all of those calculations are per pixel, we just say trellis.pixel px, py, so whatever coordinate that is, give it the faded color that we should be, and then have a small sleep in there. And then in the main loop, what we do is we just check for pressed pixels. So I have a variable called pressed, and that's equal to whatever key gets pressed. In every loop, the trellis code looks for a pressed key. And then the newly pressed is equal to the pressed minus the last pressed, so that we can keep state moving forward. If that's a newly pressed key, then we go ahead and get the x and y of that position, and then feed that up to the starburst function. And then we update that last press to the current press just to avoid duplicate hits. And then I have a small time delay in there. And so that is how we can do a starburst animation with a grid of pixels on the NeoTrellis inside of CircuitPython. And that's CircuitPython Parsec.
CircuitPython Parsec.
All right. Sorry, you probably had an echo there because I didn't mute that mic. Let's move on now. So we've got a couple things I'm going to cover. First, let's take a look at, let's do this little CAD session thing. So that's going to lead into our, put that up there, put that up there. That's going to lead into our joystick rebuild. Okay, so the very first thing is, if you look at these, I'm just going to show them up to this camera here. Actually, let me give you the down view for a second. So if you look at these, there you go. If you look at these arcade buttons, this type has a nut on here that you have to thread down the length of the arcade button, and then on the other side of your panel, you'll kind of grip this and tighten this. Problem is, it's usually a little constrained with multiple buttons next to each other, and you can't really get your fingers in there to turn that. So I did not have a socket in my set. Or actually, honestly, I didn't even look for one. I may have one from like an automotive set that's the right size for that. But I decided to 3D print a socket for this that I could just hand tighten, but it would give me a grip above. And so that's this here. That's the result of this. I put a little bit of knurling at the top here to make it a little easier to grip. And then I just used my calipers to measure out this slightly rounded hexagon, which I can now fit onto here and tighten down. I miscalculated two things when I did the first version of it. It was a little tight, and I cut out the corners on this, which turned out to be kind of neat because this is a very tight grip on it. So if you had to fit this onto something, you didn't want to drop it and you couldn't do it by hand for some reason, this is kind of an interesting little captive nut starter there that fits into there. Now this is not going to take a lot of flex before it breaks. This is just PLA, and that's the line direction of the print, so that's not super strong. But for these, I think that's actually kind of a fun, happy accident. That's not a bad way to get those started and then pull off. A little easier to just go in and start the grip if one's already in there with this, because it fits on with sort of proper tolerance there. So let's I'll show you what that looks like inside of my CAD program next, and then we'll go and take a look at this joystick. So let me turn off the preview of these. Oh, let me turn that and that off. So what I started with really was just the hexagon here. That's the proper measurement to fit over that nut. And then I wanted a very thin outer wall there. It's only like a 0.5 millimeter. That's not super strong, but I need it to be very small to fit next to the next one as we go. So you could adjust this sort of thing if you had to. So the process of putting this together is I bring in the circle there and I extrude that a certain distance. I think 43 millimeters just seemed nice. And then I do a little bit of a fillet on the corners of that hexagon and then do the same thing. And I'll show you the capped version of that actually. So that's just going to be what I cut out from the cylinder. So if I take these, I should make a shortcut key for that. If I take these, you can see that's the result of taking my hexagon, fillet rounding its corners a little bit. You can see here on this red line, and then Boolean carving that out of the cylinder. So very simple. And then the only other feature of it, if you look from the top view here, you can see I just made a little triangle, extruded triangle at a reasonable height to get a grip for some sort of fluting, kind of like knurling. Just makes it not as smooth of a surface. And the way I've got this working is I just import that and then do a polar array. So you can see here I can adjust this, I've got 66 of these arrayed around a circle. So this is gonna, let's see, am I showing the, let me disable the output just because that's doing a complex Boolean. So if I disable that, this one should let me. So there's no extras in here. They're growing in this circular array around it there. So that's how I just added a whole bunch of those triangles, and I didn't do any fancy math. I just found a number which was able to avoid the corners, because if I get too close to the corners, that's what I did on that one that ended up cut. It was smaller than the tolerance of the 3D print slice with the nozzle I was using. I think I had these a little deeper in as well, so you can see. Whoops. You can see here. Oh, that's just determined to show itself. Let me turn off grid snap. So that initial one, wherever it is what gets duplicated out. So let me undo that. Okay. And then I'll turn off that array of all of those extra little triangles there. Just hide that. And what that flows into ultimately is another solid difference where I take the initial extrusion that has the hexagon cut out of it, and I now carve out the all of those triangles. So you see that's what I'm left with, is just a little something to grip there. And you know, There's a lot of different ways to do this, but this seemed pretty straightforward. You could do it a little more parametrically based on the initial circle there. Use a second circle at some point that we blend between and have that just have little ripples in it. But this worked out well enough, so that's what I've got. And then I export that as an STL and bring that into my slicer, and we're left with this nice little guy here. And it's not the smoothest print in the world, so you'll see some little lines there that are nothing that I put in. There's a little wiggle, little ripple right there. But those are the two, so that works quite well. And now what we can do is let's jump over to the workbench there, and I'll show you this cool joystick that I got at the thrift shop. Let me put a different workbench main view over here. Yeah, so let me hop over here and grab all these parts. So this is I forget if I figured out a date on this, but this was a nice heavy joystick. It has a nice metal base on the bottom here, and there's probably not much guts inside. I know because I've opened it, but what we've got is a real arcade joystick, and this is it's not restricted, so it can do corners, so I might need to build a restrictor plate if I'm going to use that with something like Pac-Man, but it will do diagonals up, down, so there's 4 switches in there being clicked by the joystick stem, and then we've got 8 buttons here, and these are mushy and terrible. They don't feel good. They're not going to play great. You're not going to play Street Fighter or something like that with this. No Tekken for you with this. And then there's also an extra button 9 and 10, which are select and start in most cases. I plugged it into a PlayStation 1. It worked on the PlayStation 1. This will actually work on a PlayStation 1 and 2 with this connector. And then it has a USB, which makes it work on, I believe, Xbox 360 and later, as well as PCs. I had it show up on my Mac. And then there are a couple of little settings with auto and clear here that influence the little driver board. So you can, I believe, turn on a auto fire on one button, and now that one will just up as fast as it can. And you can switch this from a real D-pad to a pretend analog pad by pressing both of these. And that's important for a lot of console games where I have a proper controller here with an analog pad. But yeah, if you think about most console controllers, you'll have a analog thumbstick, and in some games it just won't read the D-pad, so let's this switch between them. So I don't think I want to change out the brain on this. The brain on it seems good. It's low latency. This is a good feature here. So really all I want to do is get better buttons in here. So we'll do a quick take apart here, and I'll show you where I'm headed with it. I'm not going to do the surgery on it today. I might just do that off camera and show you the result, because it's going to be just some straightforward soldering and not replacing the brain, like I said. So there were 4 more screws under these rubber pads, and I didn't want to lose the rubber pads by peeling them off and then trying to stick them back on. So I actually slit them with a utility knife in a little plus pattern in the middle of each. You can't really even see it, and unscrewed the screws that way. So that right there is 80%, 90% of the weight of the whole thing. It's just this big plate. And then we see what we get in here. So this is a PCB, and it's just the typical membrane switch. That's why these aren't so great. They're just typical membrane switches. This is a support, because since it's a switch being pressed on a PCB, you will crack traces over time. You'll find this in every console pretty much. If there's membrane switches on a PCB, there's got to be some nice mechanical stability for that to prevent it from flexing the PCB too much over time. So we can take that. That's just held on with 2 little Phillips screws on posts. And I'm going to leave their screws in there. That's probably a mistake. But and then there's the PCB, which is held in with 4 screws. I'll take those out. One thing I was going to try, bonus tool tip here, me trying a thing out that I got. I got a little simple magnetizer, screwdriver magnetizer. I have like a 12-volt plug-in one, but I wanted to try one of these that you can just have in your tool bag. So this, apparently you can magnetize the tip here, sure enough, and then demagnetize it here. And it's not demagnetized. And I'm not sure. That's less magnetized for sure. Yeah, I'm not sure. I'm not sure if that has to be. Yeah, they say go back and forth. All right. I've never tried this kind, so maybe they just don't work that well. That's still a little magnetized. Oh, hey, look, it worked. Okay, the tip is not. The shaft still is a bit magnetized. Hey, that worked pretty well. Okay, neat. Well, I'm going to magnetize this for the rest of this. I'll call that a win. And that's just handy compared to the plug-in one I have that plugs into the wall. And there we go, magnetized. All right. So here is, oh, one last one. I did not look at the microcontroller on here. Let's see if I can magnify it. It is INA system, I-N-N-A system, INA system, MP304010, D5F014. Never heard of it, but that's presumably the microcontroller that's dealing with everything. So, like I said, I'm going to leave that in, but this is how the buttons work. They just have I just pushed it out here. They just have little conductive pads, little not even foam. These are a little harder rubber than some that you'll see. Let me zoom in. But those are what bridge the contacts here when you press a button. Nicely labeled on there. This, it's even hard to find much info about this stick. I forget, there is a brand, I think Mayfair, M-A-Y-F-A-I-R, I think, is that right? I think Mayfair makes game input devices and dongles and things like that. I think maybe they're credited in some other people. TG Stick A2, and it's from 2006. So all this is a common ground and then the 8 pins on the microcontroller that read button presses. So my plan is going to be to just desolder this, and I can store that away somewhere if I ever want to go back to original on this for some reason. And then make a little permaproto PCB to plug in all of those arcade buttons. So go from this to a little proto board, and then these to my arcade buttons. So just for fun here, let me pop the rest of these. They have retention clips on them that hold them in place fairly well, except for that first one. And I did have to cut off, there were sort of anti-spin retention grooves that aren't really necessary, and they made the diameter a little small for the arcade buttons that I was using. So these were some custom sort of fakey arcade buttons. Really weird. I've never seen this before. Usually if something looks like it has arcade buttons, it has arcade buttons. And let me just bring up the... There we go. I'm just trying to bring up the chat here. Yeah, Andy Calloway says, nice when things are just held together with screws. So I actually am out of, I don't have enough arcade buttons to populate this yet. So I got to order a couple more. And these Adafruit ones that I really like are, there goes that. The Adafruit ones I like, they're actually they have an LED. It's these two posts here, I think, are for LED, and these are for the switch. And those can just be lit all the time off of, I can't remember what they want. I'm guessing like 3 volts and a resistor. So I'll look at that. It's not RGB or anything fancy like that, but I like these ones best even if I'm not lighting them up, which is probably the case here. I don't think I have a need to light these up. But here we go. So we'll press those in there. The nice thing is that these are little crimp spade connectors that you can just press on, so I don't need to pre-wire this or anything. I can just put that in. And first one goes on up to there by hand, not a lot of problem. But now I can come in here and tighten that up. And that's not going anywhere. Woohoo! So let's put, I think I'm going to go all blue with this. I think I'm going to order just for that kind of PlayStation look. Going to go with all blue ones, but that's not what I have in the workshop right now. So this is what's going in. And I'll try to keep the orientation consistent just so I don't end up connecting to the wrong connectors later. But again, just get it that far and then tighten it on there. Woohoo! So there we go. We'll just fill this up with what we can. Zoom this out a little bit. Like so. And this, I'm not keeping this in here. It'll get desoldered and pulled entirely. But for now, until I get that desoldered, it's just gonna flop around there. But you can see, especially if you needed to unscrew one of these once they're all in place, that's why I wanted to make a little socket for this. And it just fits between them. These have pretty tightly spaced. I don't know if there probably is some standards at this point, especially for fight sticks and things. Let's see, do I have any more? Yeah, I have one of these left. I did do tank stick, forget the brand, X-Arcade tank stick. Last year where I left, it had real buttons, I left the buttons in place, but I used an RP2040 and the GC2040 software. So I replaced the brain, kept the buttons. This is the opposite. This is, I'm keeping the brain and putting nicer butt nuts. That one won't even fit, that's too big. Put a couple of these back in just so we don't have gaps in there. There we go. So that's what that's going to look like, but I think I'll probably go all blue. So very handy. And like I said, hold it from the other side. That's ready to go. Voila. Oh no, we're buffering. Hey, that is not buffering now. Okay, good. Buffering may be over. Let's see. Yeah, YouTube is definitely having issues. No, maybe me. May not be. Well, now it's giving me green lights. Okay. I think we're back. Lars chewed through a cable again. Oh, were my last words, oh no, buffering? All right, I think we're back. So yeah, hopefully that wasn't so buffery that you couldn't see what was going on there, but that was the arcade button socket I put together. And thank you, Paul, for the warning on that. Tyeth said some were designed for 12 volts on the LEDs, so you can change the resistor for brighter or lower voltage use. Yeah, that would make sense for an arcade cabinet, I'll bet. Might be thinking of larger square clear-faced arcade buttons instead. Good question. But yeah, I don't think I'm gonna light those up at all, if I'm being honest. There's probably 5 volts floating around there because that is USB, but I think I'll leave it be and just get those working. Yeah. So, and you'd asked, and probably this got answered, but yeah, what makes an arcade button mushy? Some of it is mechanical design, so I'm sure like there are people who have favorite modern buttons, some of which even use mechanical key switches now. I think I've seen designs of arcade buttons where at the bottom is a mechanical key switch, which is interesting since it's such a high quality commodity item with so many variants on it. But this thing was yeah, look at this. Let me show this in the down shooter. This just came out. So that is presumably the capacitor or the conductive pad. Whole little rubber nub. That might be kind of useful. And that just gets pressed into that PCB and kind of smushes down a little bit, maybe before contact is strong enough to be made. So that's why it feels a little like the timing isn't great on it. But interesting that they went with kind of a whole knockoff of an arcade button design, but it's got a spring in there, but no real tactile switch. Which I think explains, does it? I thought I saw one of this little rubbery part on my bench the other day and I didn't know what it came from. So I think one of them popped out. That'll make that not work. Okay, so that's where I'm at with that. Next up, let's talk about some TB303 stuff. So I'm going to go back to a down view and a me view right there. This is, I borrowed this, but this is a modern recreation of the Roland TB303 famous acid baseline synthesizer. Let me go to a higher view there. We'll get to that later. But this layout is really similar, other than it has a modern menuing system here. But layout real similar to the TB303, which has, you can see here, 8-step sequences, which also double as a chromatic octave note input. And then the sort of central feature of it, other than the sequencer, is the filter section up here. So you can tune, you can adjust the low-pass filter frequency, cutoff frequency. You can adjust the resonance of the filter. You can adjust how much the envelope generator is going to affect that filter. And then the decay on that filter, is it end quick or does it have a little bit of a tail on it? And then how much do we do some additional VCA amplitude stuff when a note is accented? So that's what those do. And in fact, let me plug this one in and play this sequence, because if I remember, I think I have it running a sequence that's the same as on the CircuitPython version of it. So let me. This is just going to play on a speaker that I have sitting here. So it's not going to sound great. I do have like real audio into my mixer with the other demo that we'll do with Nanoloop, but this hopefully sounds like something. So let me play. And bass probably doesn't sound that bassy on my little lapel mic, but let me bring up the cutoff frequency. So here you can see this is just kind of a muted bass. Then I'll bring in resonance, which gives us some of that characteristic sound. And then as I increase that envelope mod, it emphasizes that little resonant moment. And then if I turn up accent, you can hear there's one note that goes crazy when it gets hit, because that one has an accent on it. All right, so that's the thing that we're trying to replicate here inside of CircuitPython is, at least for now, just something that can have a sequence running and can emulate some of that analog filter. So this is an analog filter in the original. This Roland one is a emulation of it. So they have some really clever digital emulation of it. Sounds great. It's also like $450. So let's try it with the CircuitPython one that's quite cheap by comparison and going to be a lot more user adjustable as far as code goes, and can do a lot of different things. So this thing that I'm plugging in here, this is the Synth IOTA board, which I'll put a link to, which Todd Kurt came up with. And this uses a lot of capacitive touch pads for things like entering notes in other software, not in this demo. Has potentiometers for adjusting exactly the sorts of things that I was just adjusting. Has a Raspberry Pi Pico or Pico 2 plugged in here. Let me get a little closer. Sorry about the glare on there. And let me get the best focus I can. The little OLED screen and push encoder, rotary encoder with a click wheel. There's MIDI in and out, UART MIDI in and out, and of course USB MIDI as well. And then this is a nice little DAC, so that's giving me my audio output there, stereo audio output. So if I play this, similar sequence. Okay, I'll take the accent out. Now I'm just adjusting that cutoff frequency. Can adjust the resonance, how much that envelope adjusts that resonant filter, and how much the accent and just like that other demo, I can transpose the whole sequence. output there. So the some of the exciting things that are happening in here, and one that I haven't experimented with, and this is kind of the first time I'm running into it. I know that there were people doing work on this, which is the effects chaining inside of Synth.io. So if I let me open up the code running on this. I might have to open a different module because it's broken up into a few. And if Todd's watching and wants to guide me on this, I want to take a look at the effects chains. So this is most of the I/O stuff on here, I think. Yeah, let me open up. I should open all these, but let's do TD-ish synth. So here it says we got a monophonic single oscillator, which can be either a saw or a square wave, same as the original. Has a portamento feature, so you can slide between notes. And then we have this VCF, the voltage-controlled filter, which in the original was a Moog-like diode ladder filter, sort of a 24 dB or maybe an 18 dB 4-pole filter, which we don't quite have a version of that in Synth.io yet. So I think this is being emulated with the biquad filter right now. And then we have the envelope generator that kind of peaks up some of those little moments there. So if we look in here, we've got these audio filters being imported, the audio filters library, and then from that distortion and filter. And so the key thing I think to being able to do this is that we're chaining together these series of filters or effects. So we have distortion, we have the actual filter low pass, we have resonance on that, we have a second filter low pass with resonance on it. We also have audio delays, which I wasn't playing with in either demo, and a distortion. So here you can see this self-effects distortion play, self-effects filter 2, and then into 2 we plug in filter 1, and into filter 1 we plug in the synth. So I'll try to, and Todd may have a demo of these, or Cooper, and I think Mark Gambler all worked on this, probably some others. I'd like to do like a simple example, a little demo where you can see like just a pure sound, maybe a square wave, and then that going through one filter and then going into a chain of filters, and how we're able to use that. So this is just like a little peek at some stuff going on, and we're using this to drive some development. So one of the things that's really difficult right now in CircuitPython is timing. So you may have noticed, if you have a good sense of rhythm, you may have noticed that there were some lagging notes here and there. And this was, I think, running at 100 BPM, but it is difficult in CircuitPython to get consistent timing with all the other things that are going on, especially as that time gets faster. If we go up to 120 BPM or higher, it starts to fall apart. And then we've also got very little going on. So I'm not entering notes in the sequence, not recording new notes. I'm not updating the screen that much. So as we do more of the things we want to do to emulate this type of a synth, we need a stronger timekeeping, either with interrupts or callbacks. So that's some stuff we're talking about right now related to this, so that we can strengthen some of the underlying fabric of having a sequence playing back, because we've got this excellent sample playback and this excellent synthesis going on. So we'll oh, do I have multiple me's up in the corner? Sorry about that. Thanks, Andy. So anyway, that's what's going on with that. If you look in the Discord chat, Todd posted some instructional materials that he has related to this, which is excellent. So go check out Todd's link there. All right, so that's what's happening with that. And then I think I just had one other thing I wanted to show. So this is, are we looking? Yeah, looking at time-wise, we're good. So another thing that we're talking about wanting to be able to do in CircuitPython Synth.io world is a small sequencer, grid style, simple Game Boy style music creation software. Might be perfect for something like a Pygamer, but could be something you use a controller on with a Fruit Jam on your TV. In fact, that's how I'm gonna show it a couple of ways. A lot of this came out of NanoLoop, which I'll put a link to. So let me show a little down shooter here. I will put just a mini me. So this is my what do we call these? Game Boy Macro. So this is a Nintendo DS Lite, which I modified, got rid of the top screen. But the original Game Boy or Nintendo DS and the DS Lite have a Game Boy Advance cartridge slot in the bottom, and they can just straight up play Game Boy Advance. So what I'm showing here is a cartridge that's made for Game Boy Advance. I just happen to be showing it on this kind of weird version of a Game Boy Advance. So here's the cartridge. This is NanoLoop 2. And the nice thing is NanoLoop exists on iOS. It's either cheap or free. It exists as a cartridge, a couple versions of the cartridge over the years, mostly for Game Boy Advance. Also exists as a standalone piece of hardware. There's a hardware version, one or two hardware versions that just do this. They aren't a Game Boy, they're just hardware with some buttons and an audio out. And it also exists as a analog pocket. That right there, I've got my analog pocket in a dock and I don't want to take it off of it, but that right there is my analog pocket, which is a FPGA Game Boy, and it has, normally you just put Game Boy cartridges in it, Game Boy Advance, Game Boy Color, but it does have NanoLoop just built in, which is the version I'll show. It doesn't want to play the cartridge. But the idea behind NanoLoop is it uses the audio engine of the device. So it uses the Game Boy Advance audio hardware, and it sequences that. And so I'll turn this on, and it's gonna be real bright. And I'll just show you this version briefly, but what I really want to show you is the one on analog. Start it. And so you can see here, we're just immediately faced with a grid. Whoa, that's real dark. Immediately faced with a grid of 16 notes, and we have 4 different voices or channels for those. So if I enter a note, we're going to hear bing. And you probably can't hear that at all, but just handheld, you got your headphones in. You can sync it with other gear, but I'll show you it in the analog dock, which I think is super cool. So I've got to just make a couple changes real quick to what's plugged in where. So I'm gonna unplug that main cam and I'm gonna plug this into the dock. All right, so there's my analog pocket showing this NanoLoop, and I can play it with a wireless controller. And then I just have to tell it to be able to play audio. So I'm gonna play this and then we can adjust audio. So tell me if you can still hear me and that, and if they're in relative balance, or if I should turn one or the other down or up. So I'll let that play for a moment, and while I do that, you can let me know which audio is working, which isn't. And I'm gonna play that again. And sounds fine. Okay, great. So what I'm gonna do is let me get rid of everything. So what you're looking at here is a set of sequences that I have, and I've just turned all of them off. 4 channels and 16 sequences. Drop music to 80% is Tyeth's recommendation. Do I have a smart way to do that? Let me try that. Let me bring this back. And that's not an obvious channel on my mixer, so let me see. Oh, I can do it. Let's try it here. my monitor a little bit so I can hear that better. Also tell me if you get a crazy echo, because I am listening in the real world, and then my lav might try to pick that up. But I'm going to proceed. Hopefully that level sounds good, and do let me know. So I'm going to put one more camera view up here. Let's do this and this. Just that, just so you can see what I'm actually doing with the controller here. It's actually the Game Boy itself, or the Analog Pocket, is kind of the nicest. Just where the buttons are and the size of them and stuff works great. But this is very similar, using this kind of a SNES style D-pad. And I just have to move that there. And I'll see in a second if I'm blocking anything important. So most of the interactions are me hitting the select button to go between two menu sets. So down at the bottom there, you see I have a couple of different menu sets. And then D-pad left and right to pick between different modes of entry for those steps that you see up above. So if I go to note entry, you can see here at the bottom I've gone to note entry. So this is all playing this C. And what I'm going to do is I'm just going to shift that octave. So did you hear my bass or my kick drum? So that's what those are. 4 on the floor right there. And then if this is my noise channel. So this is the little tick, 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 tick. I have a little delay on one of those. So if we go into note entry mode up here, tit-it, tit-it, tip, filters, adjust the filter globally here. And then we can go do them individually. If we want to kind of accent something, we can adjust the filter on just one step, which is cool. And I'm going to switch, let me switch to a different sequence. Go to this one here. Yeah, very different sequence than this one. This one's a little simpler. So one thing you'll notice about this one, so this is this S channel, which is chords. You'll notice it's moving 4 times slower than the rest of it. Here we go. Wing. Wing. Wow, these guys, you can see them zipping along. So this is a really nice feature, and one of the reasons I'm looking at this is we're talking about sequencers for CircuitPython and Syntheo. Being able to have multiple channels that are playing with subdivisions or multiplications of other sequences is a really nice way to get away from everything being super repetitive. So if we go here, let me remember how to change this one. No, I'm breaking things. I don't remember. But you can see that /4 there. That's what's saying that this one channel's sequence is playing at a quarter the rate. Another nice thing that we can do, let me reload that because I think I screwed some things up in it. And I'm just gonna So here, listen to these chords. Bum, wum, boom. So what's going on there is I've changed the individual notes to also have their own sort of probability. So that white bar on the right side of the second step, or the third step, that only plays every other time through, which is pretty cool. So if I go up into individual notes, I can say play every time. And I'm gonna up the octave on this so we can hear it a little better. Bling. Let me adjust the volume on this one too. Okay, so this should be a little louder. So now, if we go into an individual note, we can say, hey, this step, play it every other time. Or flip whichever other time. Or only 1 in 3. Or only the second in 4, and so on. So again, it's just something that I think we want to consider if we're going to do sequencing inside of CircuitPython is we don't want to paint ourselves into any corners where we can't do this sort of thing, because it's what really helps, I think, make this interesting, to be able to do probabilities of a note, to be able to do subdivisions on channels, and so on. Omri said they're certain to wake their flatmate with these tunes. All right, I'll stop here. And I'm not an expert in this, so I'm not going to do like a full tutorial on it. But I think that's interesting, minimal, like really minimal interface, which obviously you can see why you'd want that on something like a Game Boy. But look at how little there is menu diving. There's few words on it. Saving is literally heading over to one of these channels and hitting B down to save it and B up to load it. So the efficiency of the UI, I think, is pretty cool. So that is Nanoloop, and some of those things are going to be more obvious on the iPhone if you look at the iOS version of it, just because it's an iPhone, you have more UI to work with. But I would recommend checking out Nanoloop. There are other, LSDJ was a really popular tracker, is still a really popular tracker on Game Boy. I'm not looking at that, but I'm looking more at Nanoloop as a example of what you can do with a real small screen. You can imagine that would work well on little OLEDs even, and could be informative for our sequencer. All right. I think that is all I had for today. So I just want to remind you again, if you want to go get some stuff, go get it for cheaper. Head on over to Adafruit. Type in Loopy in the coupon code slot on the way out. Also, don't forget, if you have a bunch of stuff you're thinking of getting and it's not urgent, wait until you have more stuff. I know people usually don't tell you to wait to buy stuff, but if you wait and you spend $99 or more, you get a free PCB coaster with the gold Adafruit logo. If you spend $149 or more, you get the coaster as well as a free KB2040 keyboard driver. And if you're in the continental United States and you spend $199 or more, you can get the coaster, the KB2040, and free ground shipping with UPS. So those are all enticements. If you're ever wondering what enticements we have, go to adafruit.com/free, and that'll let you know what those are. So that about wraps it up. Any last words from the chats? Let me know. I think that's it. No echo. Music a touch lower than expected. Okay, I went too far the other way. All right. Thank you. That's going to do it. So come by tomorrow. Scott is going to do a deep dive. There's going to be a Foamy Guy deep dive on the weekend on his channel. I'll be back on Tuesday with product pick of the week. Wednesday morning is 3D Hangouts. Wednesday earlier evening is show and tell. And then we are waiting to see when various pre-recorded or live things from PT and Lamore will be coming back online as they continue to parent and figure things out. So no hurry there. But thank you everyone so much. Hope you have a great weekend building stuff. Let us know. Come into the chats. Let us know what you're working on. We've got a whole bunch of other places in the chat to discuss projects you're working on, general chat, questions, specific topics, all there. So go to our Discord. That's the place. All right. Thank you everyone so much for stopping by for Adafruit Industries. This has been John Park's Workshop. I have been John Park, and I plan to continue. Thank you. Bye-bye.
Thank you.